Hi everyone, my name is Zifeng Tang. I'm the first year PhD student from Professor Feng News Lab in Columbia University in the Department of the Chemical Engineering Department. And it's my honor to be here presenting my speech from amazing crowd from Far-UVC. So today I'm going to be talking about the effects of Germicidal Far-UVC on the indoor air quality in an office setting. And this is also the collaboration work between Columbia Engineering and the Columbia University Radiological Center. So there's been a growing interest in the germicidal ultraviolet light to remove pathogens from the air, especially from the wavelength from 200 to 280 nanometers. So UV utilizes the lens to emit light in the UV range to irradiate indoor air and ultimately activate the aerosol-bound pathogens. But here's the caveat: only the Far-UVC light from 200 to 35 nanometer can be safely deployed in the presence of human for the safety purpose. And here we have the GUV222 lamp from the Lumen lamps, and you can find all the detail of this product from the website listed up here. So when we look into the Far-UVC and ozone chemistry, we noticed that under the UV radiation, the ozone molecule breaks into the atoms, and then the oxygen atoms will react with the molecule to form ozone. And another interesting thing is under the UVA and B radiation, ozone would turn into oxygen, like a reverse process, but under the presence of UVC, ozone would form into oxygen would form into ozone, and this is what we focus on. And when we look into the gas phase aerosol chemistry between ozone and volatile organic compounds, they would form ultrafine particles and form aldehyde. And again, in our study, we focus more on the ultrafine particles. And these ultrafine particles would have huge effects on air pollution, human health, and climate effect. So there has been a lot of studies done investigating the effect of GUV222 on the levels of O3 and foreign particulate matters in chamber studies, hospital, and restrooms, and other sorts of different settings, amazing words. But we noticed that there hasn't been a study done in an office, indoor office setting. So here's our inspiration, and we want to answer the question: will GUV222 increase the level of O3 and ultrafine particle levels in the office setting with ventilation? So we decided to conduct our study in one of the conference room in the engineering building in Columbia, 8th floor. And we decided to conduct both 1-lamp and 4-lamp fixture experiment in the conference room, and also in the lounge area for control group experiment. We will turn on the ozone reader and the scanning mobility particle sizer in the room at the beginning to run before turning on the lamps for a period of time. And after a period of time, we will turn on the UVC lamps and record the level change of O3 and particulate matter before and after turning on the lamps. And here's a rough layout of our conference room and fixtures of our instruments. So in this study, we'll use the green SCPS 05.4 for the ultrafine particulate matter level detection, and Lumen Labs 300 as shown before. And finally, the 2B technologies Follow 202 for the ozone level detection at the top. So we also determined the air change per hour rate, around 1.3. And thanks to the colleagues from the Radiological Research Center at the medical campus, they help us to decide the fluence rate in our room for our study. So under the 1-lamp condition, the average fluence rate in the room is about 0.29 microwatt per square centimeter. And for the 4-lamp situation, accounting for the different fixtures of the lamps, The average fluence rate is around 5.19 microwatt per square centimeter. So the reason we want to conduct both 1 lamp and 4 lamp scenario is the 1 lamp scenario is recommended by the manufacturer for safety concern. However, the 4 lamp scenario will generate a higher fluence rate that matches better with the current studies done in other settings, so that we can better compare our results with theirs. So let's take a look into the actual experimental data. So here we have a figure 1A, which is the hourly average ozone readings in the conference room and outside in the lounge. And the B, we have the difference plot indicating difference in ozone level inside the conference room and in the lounge. And finally, we have the correlation between the ozone level. So in the 1 lamp situation, the ozone level difference in the two areas is very small, so that we have a more linear ozone level difference correlation in this scenario. And also notice the ozone level varies throughout the day in this experiment, and we suggest that this might be due to the outdoor ozone level influence. And again, there's a paper of our study being recently submitted to the journals under review. You can definitely find the unreviewed version in the Tang archive. So then we look at the 4 lamp situation. So this time, after the second hour, which is where we turn on the lamps, the ozone level is is a lot more different between the two areas. We have around 5 to 10 parts per billion difference after the lamp turned on in the lounge compared to the in the conference room, sorry, compared to the lounge area. And when we put these two scenarios together, you can see the difference very, very obvious. And again, finally, let's take a look into the ultrafine particle level data. So in figure 3, we have a sample run of the particle count monitoring under 1 lamp situation. So for the first 35 minutes, we turn off the light for the blank run, and after the 35 minutes, we turn on the lamp for particle count monitoring. So I haven't included the graph for the 4 lamp situation, but you can definitely find them in the paper. But here in the table 1, we listed the exhaustive data for both scenarios for the percent change and the amount change of the average particle count before and after the lamp turned on. Again, notice for the 1 lamp situation, the level change before and after the lamp turn on is very small, almost no change. However, for the 4 lamp scenario, there's like a 16% level increase after the lamp turn on. So in conclusion, we suggest that a single lamp does not significantly contribute to the ozone level increase and far particulate matters increase. However, under the 4 lamp scenario, there's about 5 to 10 parts per billion ozone level increase compared to the background level in the lounge, and some increase of the particulate matter level as well. And this result is kind of similar to a lot of the studies done in the chambers, hotel rooms, and other scenarios. And finally, we suggest the use of GUV222 at low intensities, and in coordination with adequate ventilation, may reduce airborne pathogen levels while minimizing the formation of air pollutants. And here's the list of acknowledgements for our study, and that's it. Thank you very much.